A single-page application is a type of a modern web application where the user only needs to load the web page for once. In other words, the user will only need to download all the static assets, for example, the CSS and JavaScript files for only one time, and rely on client-side routing to navigate around the web app. By client-side routing, we simply means a mechanism to swap the content in a DOM with another without refreshing the page. We are really changing what's to show and what's not to show in a page, and hence the name single page application. Thankfully, we didn't need to do much work for client-side routing because React provided us a library called the React Router, which will do all the hard work for us. Let's see how we can install and use React Router in our project. First of all, we'll go to the documentation and head to the quick start guide. And if we look at the sample code, it is fairly simple for us to set up React Router. At the time of recording this video, the latest version is version 6, so be mindful of the syntax if you're using a different version. Anyway, if we look at a code snippet here, the first thing that we want to do is to wrap everything within a browser router component. This component will initialize React Router and allow us to use the routing logic in its children. Next, we have the routes component, and that is where we're going to define all the routes in our app within it. It looks a bit scary now, it's okay, we'll go through it together one by one. Let's first install React Router in our project. I'll copy the npm install command and paste it inside our terminal. Once that's done, we'll go to our app.jsx and initialize the React Router structure as we have seen inside the documentation. We will have the browser router, followed by the routes component, and I'll also clear out all the dummy elements that we have created previously. Now within the routes tag is where we will define our client-side routes. Generally speaking, all the components that we created inside the pages folder will need to have a route. At the moment, we have a contact page and a home page. Let's create a route for the home page. To do that, within the routes tag, we will load a route component from React Router and pass in our home page component into the elements prop. Now you'll notice that the autocomplete doesn't work. This is a quirk of VS Code, so if you want VS Code to auto-import a React component for you, we'll need to pass in the props argument inside the component function, which currently does not exist inside the home component. And now back to app.js, we can see that the autocomplete triggers will now show our homepage component, and we'll hit tab to auto-import the component. Once we have specified the element for the route, we need to define the password. So in order for us to visit the home page, the user will need to visit the root route, which is a simple slash for the path props. And while we're here, let's quickly create another route for our contact page as well. Once we're done, let's go to the browser. We are at the root route at the moment, so the home page is rendering. However, if I change the URI to /contact, we get a different component rendered in a DOM. Beautiful. And that is the basic of registering client-side routes in React Router. One important note here is that we should not put any other component than the route component within the routes tag. Otherwise, React Router will complain. We'll continue in the next lesson. Alright, key takeaways for this lesson. Single page application, or SPA for short, is a type of modern web app where we need to download the static assets for only once. SPA utilizes client-side routing for page navigation, and React Router is a client-side routing library for React applications. In order to register routes in our application, we need to use the browser router, routes, and route components from the React Router library. That's it for now, and I'll see you again in the next video. Building a single-page application means that we can't use a tag to do our in-app navigation, because the moment when we click on an a tag, the whole page will refresh, and that defeats the purpose of a single-page application. So React Router has provided us a drop-in replacement for the a tag, and it is something called the link component. Let me show you how it works. We'll learn how to use the link component by building our application's navigation bar. So let's go to our navbar component. At the moment, we're rendering the navbar item using a function called render navItems. And the function is based on the variable navItems to generate the list. Now the function is simply returning a list item element followed by an a tag. As we discussed, we should not use the A tag in a React app. What we should do instead is to import the link component provided by React Router. Let's go ahead and do that. The link component works very similarly to an A tag, but instead of using the href attribute, we have to pass in the two props to specify the link destination. And that's it. Let's edit our nav item array so that each link item can point to the correct URL. I would also like to change the href property so it makes more sense. Alright, let's see how it looks like in the browser. Our navbar still looks exactly the same as before. However, this time, when I click on the link, our page does not refresh. How good is that? And that is the essence of a single page application. We will keep looking at some other features of React Router in the next few videos. I'll see you there. Key takeaways for this lesson. We shouldn't use anchor tags in a single page application because clicking on an anchor tag will cause the whole page to refresh, and that defeats the purpose of a single page application. What we can do instead is to use the link component provided by React Router to replace the anchor tags. That's it for now, and I'll see you again in the next video. There are instances where we want to do a programmatic navigation. In other words, using JavaScript to navigate the user to a different page without the user clicking on a link. This is particularly useful when we want to restrict access for a certain page in our app. For example, if the user tried to access the admin area, we might want to kick the user out, or if the user tried to visit the app dashboard without logging in, we might want to redirect the user to the login page. In these kinds of scenarios, we'll need to use JavaScript to run a check and redirect the user to the appropriate page. And now, let's see how this thing works in React Router. Let's create a new dummy admin page and I'll show you how it works. I'll create a new folder in our pages directory and I'll call it admin. And in there, I'll create a new file. Then we'll go ahead and add a new route in our app.jsx. Now back inside our dashboard file, this is in our admin area and we don't want our average user to come here and party. Typically speaking, we'll use a use effect to run a check when a component was mounted. And the check will determine whether the user is an admin or not. If not, then we'll kick the user out. We don't have any authentication mechanism here, so we'll just hardcode the check. I'll just assume everyone who visited this page is not an admin. And now, time for the main redirection logic. It's actually quite simple and straightforward. First of all, we need to call a hook function provided by React Router, and the hook function is called useNavigate. The hook function will return us a navigate function where we can use it to navigate the user around our app. So once we got the navigate function, we simply need to call it inside our if statement. So if the user is not an admin, we'll simply redirect the user to the root. Alright, let's test our code now. And just for testing purposes, I'll go to our navbar and add a new link that will send the user to our admin dashboard. Alright, let's go to our browser and see if this is working. Now when I try to click on the admin button in our navbar, the app will simply redirect me to the home page. And that means our redirection logic is working. Let's try to remove the check for now and see the admin page is rendered properly. Okay, so now when I click on the admin button, we can see our dashboard page. Great! Now typically, we would wrap our admin dashboard inside an admin layout, and we'll put this admin check logic inside the admin layout, since it is required by almost all of the admin components. Alright, that was a quick intro to the useNavigate hook function. Key takeaways for this lesson. The useNavigate hook function allows us to programmatically redirect the user. It will return us a navigate function where we can use it whenever we want to redirect the user in our code. That's it for now, and I'll see you again in the next lesson. As we are building our application, it is unavoidable that we would have routes that has the same prefix. For example, let's say we have a few admin routes: admin dashboard, admin manage, and admin settings. Now all of these routes has the same prefix called admin. However, if we write our route component just like what I did here, it is not that pretty, because we're essentially repeating ourselves. So how can we improve this situation then? React Router has a solution for us, and it is called route grouping. Rather than declaring the routes one by one, What we can do instead is to have a parent route component where we define the admin path prefix on it, and within the route component, we'll define the individual children routes. One important point here to note is that we could not put a slash in front of our route path, because a slash means an absolute path in React Router. If we put a slash in front of the path, that means when a user visits the slash dashboard endpoint, we would like to serve the user the dashboard component. And that defeats the purpose of route grouping altogether. Anyway, let's visit our browser now to make sure that everything is working correctly. So if we visit the admin dashboard, we can see that the dashboard component is rendered properly. If I go to the manage endpoint and the settings endpoint, they're all working fine. Beautiful. Alright, let's move on. Now there's always a situation where we need a dynamic route. For example, an admin page where we can manage a specific user. So the routes will look something like this: /manage /users /the user ID. So if we put 1 as the user ID, we will be seeing the details of user 1 on this management page, so on and so forth. Now the question is, how do we implement this in React Router? It is actually pretty simple. Let's duplicate the manage route component, and what we need to do to make the route dynamic is to use a colon and a parameter name to represent the dynamic parameter. Once we have done that, let's go to the browser and test this one out. We will visit the admin manage user endpoint, followed by any random URL parameter, and we're greeted by the dashboard component. Great, but now we got a new problem. How do we retrieve the dynamic URL parameter? To do that, we'll need to use a hook called useParam. Let me show you how it works. Let's go to our dashboard component, and I'll import the hook useParam from the React Router DOM library. The hook will return us an object that represents all the URL parameters in the current React route. Now I'll go ahead and console log out this param object, and let's see what will happen inside the browser. We'll go to the console, and as you can see here, it is the object that contains the user ID URL parameter. The value is whatever we put inside the URL, and the key refers to the name of the parameter that we registered inside the React route component. And now we can go ahead and use this parameter however we wish inside the component. For example, let's add the value of the parameter after our dashboard heading. And now if we go back to the browser, whatever we put in the URL parameter will show up directly after the word dashboard inside our DOM. How cool is that? And if we try to visit a route that does not have a URL parameter, the param object will simply be an empty object. Alright, that was a brief introduction to route grouping and dynamic route in React. We will continue in the next lesson. Key takeaways for this lesson: we can put additional route components within another to group multiple routes together. We define dynamic routes by using the colon syntax. useParam is a hook that allows us to retrieve the dynamic route parameters. That's it for now, and I'll see you again in the next lesson. The Windows object in the browser has a module called location that allows us to get information about the current route. Although we can use the location module to get the current route's information, however, the React Router library does provide us a hook function that can replace the location module in a Windows object. In general, if we're using the useLocation hook, we can get more information about the current route in comparison to use the location module in a Windows object. Let me show you how the useLocation hook works. We'll go to our public layout component and import the useLocation hook from the React Router library. And just for demonstration, I'll console log out the result of the hook and see what information is available to us. And now as you can see here, the location object contains a few properties. The hash and key properties are used internally by React Router, and we don't need to worry about them for now. Essentially, they are the unique identifier for each route that we registered inside the React Router. Path name represents the URI that we're currently visiting, and search is the query parameter in our URL. Let me show you how these two properties work. If I visit a contact page, notice that how the path name property has changed to /contact. And if we manually add a query parameter to our current URL, let's see what would the search property change to. The search property would just be everything after the question mark in our URL. Now the state property is one of the most important properties in this location object. This is the main way where we can pass information across different pages in our React project. Let's look at an example. We will go to our home page component and let's create a button that will redirect us to the contact page. Now for us to utilize the state property inside the location object, we will need to use the navigate hook to perform the redirection. So in the button event listener, I'll go ahead and call the navigate function, but this time I'll pass in a second argument. Now the second argument is an object that could contain two properties. The first property is the replace property, and the second property is a state property. The replace option is a boolean, and if we set it to true, then this navigation will replace the latest route in the redirection history stack. In other words, if we set replace to true, that means when we click the back page button in our browser, the browser will be unable to return us to the previous page. Now the state property will let us to put in any arbitrary data that we would like to pass to the next page. In this case, I'll simply pass in a dummy object. And let's see what will happen in a location object now. Let's go back to the home page in our browser, and I'll go ahead and click on a button and take a good look at the location object that we were printing out in the browser console. We now got a state property, and it is exactly the state that we pass inside the navigate function. We have just successfully passed a data from the home page to the contact page. And now you might be wondering, how could this be useful to us? Let's consider this scenario. Suppose we have an admin page that allows us to manage all the users. Now we would have a page that lists all of the current users that are using our app. Each of the table row represents a user record, and each of them would have a button that allows us to go to the edit page and edit the corresponding user's profile. Now logically speaking, we will need to call an API to get all the user information when we are at the first page. Upon clicking on a row, we somehow have to display the user information on the edit page. Now the question is, do we really need to call another API to grab the information of this specific user? The argument is that we've got the user data already in the listing page. Why don't we just pass the user information to the edit page? That way we can make one less API call to the server. And to achieve this, we can totally pass the user data to the user details page using the state property in React Router. So when we are visiting the edit page, the page will load directly without calling an API, and this will greatly improve the user experience in using the app. Alright, we'll continue to talk more about React Router in the next lesson. Key takeaways for this lesson: the use location hook provides us an alternative way to retrieve URL information in contrast to using the location module in a window object. We can pass data to another page by utilizing the state property in navigation. We can do that by passing in another argument in the navigate hook function. That's it for now, and I will see you again in the next lesson. The way that we define routes in React Router might look a little bit odd to some people, since we're using XML tags to define these routes. The syntax might look a little bit strange, and to some people, it's not that comfortable. If you're that person, well, I've got some good news for you. React Router actually provided us a hook for us to define the routes in the form of a JavaScript object. Now let's take a look at the syntax. First of all, we'll need to import the use routes hook. The hook function will receive an array of routes object, and each object is basically the equivalent of the route component. Whatever props that we can pass to the route component, we can do the same in the route object counterpart here. So let's try to replicate our current route structure into the use routes hook. First of all, we have the root route where I'll set a path to the root and the element to the home component. Next, we have the contact page, and I'll do the same as the home page component. So far, so good. Next, to replicate the admin route group, we'll need to use the children property. The children property is basically another array of routes, and each object would have the exact same structure as what we already have so far. Alright, now we're done. Let's test our code. I'll comment out the XML syntax and replace it with the routes JavaScript variable created by the hook. Okay, let's go to the browser and see what will happen. Whoops, we're greeted by a lot of errors. It says that the useRoutes hook function can only be used inside a router component. This is an easy fix. We simply need to refactor the browser router component from our app.jsx into the main.jsx file by wrapping it around our app component. And now let's go back to our browser, and our app is now rendered properly once again. And clicking on a link in the navbar will redirect us to a different page, just like before. And that means the useRoute hook function is working properly as a substitute of the XML syntax. And that's it. You can use whichever syntax that you prefer. Either way, they'll work just fine. Alright, key takeaways for this lesson. useRoutes is a hook function that allows us to define routes in JavaScript object syntax in contrast to the XML syntax. We can only call useRoutes within the browser router component, otherwise React will complain and refuse to render the page. That's it for now, and I'll see you again in the next lesson. When we visit a URL in an app, we are actually sending a GET request to a known endpoint in the server, and the server will send us the corresponding page. Now React Router is a client-side routing service, and that means the server wouldn't have known about the route registered in the React Router. So that means if we try to send a GET request with a route defined inside the React Router to the server is likely to send us back a 404 response because the route was registered inside the client side, not the server side. This could be a problem if we do not have control over the server-side code. For example, if we want to deploy our app on a static site hosting provider like GitHub Pages or Netlify, then our app should not work. So how do we solve this problem then? The answer is to use something called Hash Router, which is an alternative router provided by the React Router library. Let me show you how it works. Let's go to our code. We will go to our main.jsx file, and currently, as you can see, we're using the browser router. If we want to change it to the hash router, we simply need to change the import to hash router instead of the browser router, and load hash router inside the render function. Let's go to the browser and take a look at the behavior of the hash router. So currently, we are in the home page, and if I click on the contact link in the navbar, notice what is happening inside the URL bar. Instead of having a full URL, we have a hash sign in between the primary domain and the contact URI. And that is exactly the difference between a browser router and a hash router. The URI that you're seeing now is actually a fake URI that was not loaded from the server side, but instead from the client side. And to clarify the concept once again, we are sending a request to the backend server by the root endpoint. Once the server sends us back the React application, then React Router will take it from there by looking at what's after the hash sign and render the page accordingly. That way, the server does not need to know about the contact endpoint because it was handled by the React Router on the client side. And hence, in theory, our React app should work in any static hosting provider. And there you have it. That was a brief introduction to hash router in React. In general, I would not suggest you to use the hash router unless it is necessary. If you can use the browser router, then by all means, use it. Only use the hash router when there's no other workarounds. And if you're wondering why is the browser router working in our local development environment, it is because the Vite development server is handling all the routing logic for us behind the scene. It is acting as a web server for our React app. There are also other routers that we can use in our React project, like the memory router or static router. However, they are a bit more advanced, so maybe we'll talk about them in a future episode. Alright, we'll continue in the next lesson. Key takeaways for this lesson. Hash router is an alternative router to use when we can't register routes in a web server for some reason. React Router will render the page based on a hash portion in the URL if we are using the hash router. That's it for now, and I'll see you again in the next video. I'm sure that you have been to some websites where you visit a new page where the majority of the layout is the same as the previous page, but only a small part of the page is different. For example, let's say we are in a management page in an admin dashboard of an app. The left-hand side here is a sidebar where we can navigate to a different page in our admin area, and in the middle of the page, we have the management page title, followed by a section with multiple tabs. And upon visiting each tab, they will contain a different settings and configuration respectively. Now the content of each tab is fundamentally different to each other. However, each of these tabs should have their own URL, and the overall layout of this management page should still be the same. In other words, we would like to keep the appearance of this page consistent. And the question is, how do we solve this problem? And now you might be thinking, why don't we use layout? Well, you see, the admin area could have a lot of pages, and each page could have their own appearance and layout. The main layout of the admin area should only be used for things like the sidebar and the navigation bar. Layout is not exactly useful for the internal page content. So how can we solve this? Our solution here should be something like a secondary layout that is localized to a certain page. And thankfully, React Router does provide us this feature, and it is something called outlet. Let's see how this thing works. First of all, let's create a new folder called settings, and inside here, I'm going to create a new page called settings index, which will be the main page for all the settings. And inside this component, it is where we are going to put the tabs. Let's create a simple layout for now. I'll go ahead and create a list that contains 3 links that will navigate the user to the other settings page. And underneath the links is where we want to show the different content of each page. To show the content of each page, we will need to import a new component from the React Router library, which is called the outlet component. And now I'll go ahead and create the other setting pages. And also register the routes inside our app.jsx. Once we're done, let's go to our browser and test it out. Let's go to the admin settings URL, and let's see what will happen if I click on any of the link inside the list. Since they're all using the same layout, the only thing that's changing for each page is the content section, which is exactly what we wanted. Alright, so outlet is basically a secondary layout that is useful in a localized context. It is a very handy tool that can help us tremendously, especially when our route is deeply nested. Alright, key takeaways for this lesson. Outlet is a special component provided by React Router for us to load child component. The notion is like layout, but localized to part of the app. That's it for now, and I'll see you again in the next video. React Router introduced a new API to define routes since version 6.4. It is known as the so-called Data API. Let's see what's the big deal about it. The main goal of this Data API is to make routing a lot more flexible and modular, so we can use it comfortably across our React app. There's a few changes in the new API. First of all, let's refactor our code. We'll go to our main JSX file and refactor on how we registered the browser router. Here's how it works. In the Data API, we'll need to call the create browser router function to create the browser router. The argument will accept an array of route objects, and they are the same as what we have already defined inside our app.js in the use routes hook. So we can simply cut and paste it over to our main JSX file. So once we have created our router, the next step will be registering this router. What we need to do is to call a new component called router provider and pass our router variable in as a prop. And that's it, we're done. So technically speaking, we don't really need our app.jsx component, since we're now defining our routes inside the main JSX file. Let's go ahead and delete the app component, and also import all the page components inside our main JSX file. And now let's go to the browser and take a look at our app. And as you can see, everything is still working as before. Now the Data API is not just a change in the API on how we load the router. It also provided us a number of powerful features that can help us tremendously in building our front-end SPA. The most notable features are the action and loader functions that we can attach to a route. Let's look at the documentation to look at the syntax. So loader is essentially a function that will be triggered before the page is mounted. It could be useful for us to call API requests that will fetch data required by the page. Action, on the other hand, will be triggered whenever there's a non-get HTTP request calling upon the page. This function was typically triggered whenever there's a form submission. Anyway, that was a quick introduction. We will discuss more about the details in the next lesson. I'll see you there. Key takeaways for this lesson. Data API is an alternative syntax for us to define and register the routes in React Router. Data API offers a more flexible and modular API. The loader function is called when a page is mounted, and the action function is triggered when there's a non-get HTTP request that was called against the page. That's it for now, and I'll see you again in the next video. We mentioned in a previous video that the loader in the data API is a way for us to trigger a function when a page is mounted. Let's see how this thing works. First of all, I'm going to create a new page called user details. And we'll use this endpoint to demonstrate the use of the loader. Now the loader is simply a new property inside the route object. It is a function that takes in one argument, which is an object. And inside the argument, there are two things. The first one is the URL parameter, which in our case, the parameter will be the only one and only user ID that we have inside the path property. And the second one is the instance of the HTTP request called against the current endpoint. At this point, some of you might be thinking, hold on, what is this HTTP request presenting anyway?
Wait a minute.
Let's step back for a moment and think about this. Imagine we're using a traditional web application where we are using server-side routing. Now, if we want to visit this URL, we have to physically click on a link, and the link will send a request to the server, and the server will send us back the HTML page. Now, this request argument is meant to be the request sent to the server. However, in our current situation, since we're building an SPA, there's no need for us to send a request to the server, but the loader function will capture the request for us anyway, just in case if we need it. Let's console log out both the parameter and the request, and we'll see them for ourselves. Let's go to our browser. If I visit the manage user URL, then we can see inside our console, we have a parameter and a request. The parameter has user ID set to 1, which is exactly the same as our URL, and for the request object, it is a GET request with the URL the same as our current URL in the browser. Alright, these are just the information that we can grab from the loader function. Now, we can do pretty much anything inside the loader function, but the typical use case is for us to fetch our application data from the server using an API and return a result to our component. Whatever we return inside the loader function is accessible inside the component. Just for demonstration, we can return a simple object here. And let's go to our user details component, and we'll learn how to get the data returned by the loader. To do that, we'll need to use a hook function called useLoaderData. And now if we console log out the loader data variable, and let's go back to our browser, we can see that it is printing out the exact object that we return inside the loader function. How cool is that? We could also return a HTTP response object inside the loader function. And behind the scene, React Router will automatically convert the response into a JavaScript object to our component. In fact, React Router does provide us a helper function called JSON that will convert any object into a new response object. And if we hover on a function, we can see in the documentation, it is returning us the response type as the end result. Now, if we go back to our browser, we could still see that the user detail component was able to grab the data correctly. Alright, it is a good place to stop here. We will continue in the next lesson. Key takeaways for this lesson. The loader function will be triggered when a page is mounted in a DOM. We can only use the loader function only if we're using the data API. In other words, creating the router using the create browser router function. We could return anything inside the loader function, and if we decided to return an HTTP response instance, React Router will convert it into a JavaScript object automatically. That's it for now, and I'll see you again in the next video. In contrast to loader, action is a function that will be triggered whenever a page sends out a non-get HTTP request. In other words, we'll most likely trigger it whenever the user submits a form. And now let's see how we can get started with the action function. Similar to loader, we can define the action function inside the route object. And just like its sibling, it will also take in an argument that contains two properties, the parameter and the request object. Parameter is referring to the dynamic parameter inside the URL, and the request is the outgoing HTTP request. We'll console log out both the parameters and the request inside the function body just for demonstration. And now let's see how we can trigger the action function. Let's go to our user details component and let's build a form so we can have form submission to trigger the action function. Now we can't use the native HTML form because it doesn't work nicely with React Router. What we should do instead is to use a form component provided by the React Router library, and this API is very similar to the native HTML form. We'll provide an action prop and also a method prop. And within the form, we'll create an input field and give it a name of email. And we'll give it a little bit of styling so that it's not that ugly. Alright, let's go to our browser and give this a go. I'll enter some random things inside the text input and hit enter. And we can see that in the console logs that we entered earlier has appeared. And they're logging the parameter and the request of this form submission. Now what we would write inside the action function is really up to us. Typically, we would write the corresponding functions to send the API request to the server. And to do that, we often need to read the body of the request. And React Router makes it simple for us. We just need to read the form data method from the request object inside the action function. The form data method returns us a promise, so it might be better for us to use a wait here. And we'll also console log out the form data just for demonstration. And now if we go back to the browser, upon submitting the form, we can see the form data printed out in the console. Now this form data is a native form data object where we can't read the content directly. If you want to read the payload of the form data, what we can do here instead is to convert it into an object by using the object from entries method provided by JavaScript natively. Let's try again. And now we can see the content inside our form data. The key is the name of the input and the value is whatever I have just entered inside the text field. Isn't that neat? Alright, let's move on. Similar to loader, we can return whatever we want inside the action function. Typically speaking, we will return the result of the API request. Let's quickly mock up some response here. And let's say the API returns us an object that contains an error saying that the email that we just entered has an invalid format and is wrong. Now the UI will need to receive this message and display it to the user. To get the result of an action, we need to call another hook called useActionData. Let's console log out the action data just for demonstration, and we'll go back to the browser. At the very beginning, when the component was first mounted, the action data is undefined because the action function hasn't been run yet. Now if we submit the form, we can now see that action data has now got a value, and the value is exactly what we have returned inside the action function. And now we can go ahead and show this message inside our UI. Let's do that. We will put the error message directly underneath our input field. So the idea here is that we will write a short circuit that checks if the error field is presented inside the action data. We are using the question mark optional chaining operator here to check if action data is undefined or not, so that our code doesn't break. So if the error field is presented inside the object, then we will load a span that shows the error message. Alright, let's go back to the browser and run this bad boy. And now the moment when I submit the form, the error message shows up, which is exactly what we expected. Okay, so that was a quick overview on how the action function works in React Router. We will continue to dive deeper into the other features provided by the React Router in the next lesson. I'll see you there. Key takeaways for this lesson. Action is triggered when a component submitted a non-get HTTP request. Just like the loader function, the action function receives the URL parameter and the outgoing HTTP request instance in its argument. We can receive the result of the action function through the useActionData hook. This is particularly useful when we want to display the error message from the API or the success response from the API result. That's it for now, and I'll see you again in the next video. Sometimes we need a way to manually run our loader and action function programmatically. As we stand now, there's no way for us to run the loader and action function manually. The loader is triggered whenever the component was mounted to the DOM, while the action is triggered when we submit the form. Now there's a good number of reasons why we might want to programmatically trigger these two functions. For example, if we want to refetch the data from the API server, we need to rerun the loader function. Or when we want to perform some sort of custom validation in a form, we might want to trigger the action function manually after we have checked all the user input inside the form. Now, in order for us to run the loader and action function programmatically, we will need to use a new hook called useFetcher. In short, the useFetcher hook will return us a fetcher object that provided us a handy API to work with the loader and the action. Let's see how this thing works. To get started, we first need to call the useFetcher hook. Now, to programmatically call the loader function, we can use the load method provided by the fetcher object. And just for demonstration, I'll chuck a use effect here and manually call the load function after 2 seconds. Now when we call the load method from the fetcher object, we gotta pass in an argument. And the argument is the URL of the route. In our case, we wish to call the loader function of the user details page. Therefore, we simply need to chuck in the URL of the user details page inside the load function. A takeaway here is that you can technically call any loader function in your app by using the fetcher load method. You just need to pass in the correct URL. Now it is very common that we need to call the loader function of the current route. And if you're like me, where I have got a very bad memory, when I don't even remember what I had for breakfast today, I'll be honest with you, I can't remember what the current route is. To make our life better and lazier, what we can do here is we can call the useLocation hook to grab the location object. And from the location object, we can read the path name property to get the current route. That way, we can simply call the load function dynamically, and even if in the future, if we change the URL, our page would still work. And just for demonstration, I'll console log out some message inside our loader function, and we'll give this bad boy a run. We'll head to our browser, and upon clicking on the refresh button, take a look at a console. When a component was mounted, we see ABC gets printed out for the first time. And after 2 seconds, the loader function gets triggered again, and therefore we see another ABC. Again, we're seeing 2 ABCs in a second console log because we are currently having strict mode turned on. So far, so good. Let's move on. We will see how to programmatically run the action function in our code. To do that, we'll call the submit method on our fetcher object. The first argument is the payload of this submit request. Whatever you put inside here will become the body of the request. You can also put in an HTML form element here if you wish. We will set it to null at the time being. Now the second argument is the important one. It is an object for us to configure the method and the action of the submit request. So we can specify our method to be post here, and the action is the URL of the submit request, so we can just use location.pathname. If you want to call a different action function, simply supply the corresponding URL inside the action option. Next, I'll modify the action function so it's more obvious in our browser console log. Alright, let's give this a go. We'll go to our browser, refresh the page, and as you can see here, our component did send out an action request. However, if you look at the form data inside our request, it's empty at the moment because we have set null as the first argument inside the submit function. Let's fix that. I'll put in some dummy value as the body, and let's see what happens next. Back to our browser, hit refresh, and now we see hey you inside the form data. Isn't that simple? Alright, let's move on. So the fetcher object does provide us some other properties that we can use over the life cycle of a submit request. For example, we can read the state of the fetcher by reading the state property on the fetcher object. The state is a string that can either be one of these three: idle, submitting, or loading. The state is idle when nothing is being fetched. it is submitting when the form is sending out the request, and it is loading when the loader is being called. The form data property is the form data inside the payload of the submission request. Form action is the target URL of the form submission, and form method is the corresponding method. The data property is the return result of either the action or the loader function, depending on which one is calling in a life cycle. And lastly, form enc type is the encoding type of the submission. It could be JSON or form data. And now let's go to the browser and look at how this console log will turn out inside the console. Okay, now you can see that initially all the fields are undefined because there was no form submission when the component was first mounted, and the state is idle initially. However, after 2 seconds, the state becomes submitting, and we can see that there's something popping up for each of the property. The form data is a form data object where we need to unpack it to see the data inside it using object.fromEntries. We'll do that shortly just for demonstration. And we can see the URL of the submitting target and also the method, but the data is undefined because the data property represents the data returned by the action function, which is not resolved yet. And if we go further down inside the console log history, towards the end, once everything is settled, the state changed back into idle, and the form data, form action, form method, and etc. became undefined again. However, this time, the data property is now showing the result of the action function, and that is exactly what we are expecting. And now let's go back to our code and try to unpack the form data so we can see that inside our console log. As discussed previously, in order for us to convert form data into object, we simply need to call the object.fromEntries function, and that should just work. However, we do have an issue here. The form data property could be undefined, and if we put undefined inside the fromEntries function, JavaScript will not be happy about it. So what we should do here is to give this fromEntries a fallback. The form data is undefined, then we'll give it a fallback of an empty new form data object, and that should do the job. Let's go back to our browser. And as you can see inside the console, we're able to see the content of the form data object now. And one last thing before we end the lesson, the fetcher object actually provided us another property called form, and it is a non-navigating substitute for the default form component provided by React Router. The default behavior of the form component is that React Router will redirect us to the action URL once we have submitted the form. If we don't want this default behavior, then we can use the fetcher form component instead. Alright, that's basically everything that we need to know about the fetcher API. We'll go deeper into the React Router in the next lesson. Alright, key takeaways for this lesson. The useFetcher hook returns us a fetcher object that contains a powerful API to programmatically trigger the loader and action function of a particular route. The load function on a fetcher object will trigger the loader, while the submit function will trigger the action. The form property inside the fetcher object is a non-navigating version of the default form element provided by React Router. The state property can either be idle, submitting, or loading. This is useful to render the loading UI of a particular component. That's it for now, and I'll see you again in the next video. Revalidation is a concept where the loader function of a route gets re-triggered when we submit the form. By default, React Router will re-trigger the loader function, in other words, revalidate the component under a few conditions. And if we look at the documentation here, this few dot points simply outlines the condition where the component will be revalidated. Essentially, when the action function is called after a form submission or when a URL is changed. If you find this confusing, don't worry. Let's look at revalidation in action. No pun intended. Now we're inside the user details page, and currently this route has a loader. And as I mentioned earlier, as we submit a form, React Router will revalidate the route, in other words, call the loader function. So that means when we call the submit function on the fetcher object, it will trigger the revalidation and therefore running the loader function. Let's go to the browser and test our theory. I'll refresh the page. Initially, the loader function runs when a route was loaded. However, after 2 seconds, we run the submit method on the fetcher object and therefore triggering revalidation, and we can see our console log is printing out loader loading once again. While revalidation is triggered by React Router automatically behind the scene, sometimes we do need the power to trigger it manually. And to do that, we need to call another hook called use revalidator. Let me show you how it works. First of all, we will call the use revalidator hook to create a revalidator object. And we'll go ahead and call the revalidate function from the revalidator object inside our setTimeout. So in theory, if we go back to the browser now, we should see our loader function get called after 2 seconds, as you can see inside our browser's console log here. Calling the revalidate function is exactly the same as we call the load function on the fetcher object against the current route. It is pretty rare that we need to call the revalidate function, but this feature is here if you ever need it. The main purpose is to get the page to reload all the data, so we will have the latest data in the UI. Now there are instances where we only want to revalidate under a certain condition. If you want to define a condition on when to revalidate the page, we can simply define a should revalidate property inside the route object. Let's go back to the main JSX file and we will add a new property called should revalidate, which is a function, and the function will set an argument that contains all sorts of information that might be useful for us. I'll console log it out for us to see what's inside it. And this function should return us a boolean that determines whether we should revalidate the current route or not. I will return false for now, and let's see what will happen. And remember, we are triggering the revalidate function inside our user details page after 2 seconds upon the page is rendered. And we're returning false inside the should revalidate function, so in theory, our loader function will not be triggered for a second time after 2 seconds. Alright, let's refresh our page. And after 2 seconds, we only see the ask argument gets printed out inside the console, and the loader function was not triggered because the should revalidate function is returning false. And now let's take a look at what's inside the argument of the should revalidate function. It is an object that contains the URL information and also the return result of the action function of the current route, which is nice. And that means we can control whether to recall the loader function depending on what the action function is returning us. If the action function has failed, we might not want to call the loader function in the current route. I would suggest you to take a quick look at the documentation to find out more about the revalidator. Alright, key takeaways for this lesson. Revalidation is the notion of retriggering the loader function of the current route to get a fresh dataset for the current page. Upon submitting or changing the current route's URL parameter, React Router will automatically revalidate the route. We can manually revalidate the route by calling the revalidate function on the revalidator object. That's it for now, and I'll see you again in the next lesson. As our app grows larger and larger, it is unavoidable that we're going to have a lot of routes. Having a good way to organize these routes in our React project can really help us to go a long way. You don't really want to manage 1,000 lines inside the main JSX file, do you? Let me show you a quick technique on how I organize my routes in my React project. On the fundamental level, the route object are basically JavaScript objects, and they're living inside an array. So technically speaking, we could have splitted this array into groups and combine them all together back inside the correct browser router function. I will show you what I mean. So currently in our sample app here, we have a few routes which are what we consider as public pages. So I can create a new array here and I'll call it public routes, and I'll put those routes inside this array. And we also got an admin routes. Again, I'll create another array and put the admin routes into this array. Now back inside our correct browser router function, we can now unpack those routes into the array. Isn't that neat? So now our correct browser router function is very clean and easy to understand. The next step is to move this routes array into their own file and import them inside this main JSX file, so we can keep our main JSX file as clean as possible. Let's create a new folder called routes inside our source directory, and we'll go ahead and create 2 files in there. for our admin routes and public routes. Once we're done, we'll move all the corresponding routes logic into these two files, and also export the route array in each of these files. Once we're done, we just need to import them back inside our main JSX file. And that's it. Let's go to our browser and test our app and see if it is still working. Whoops, we've got an error. It says failed to resolve import. This is because we have changed our folder structure and the import routes that we copy over is no longer referencing the correct file. Let's fix that. Currently, our routes file is living inside the routes folder. And that means in order for us to access the pages folder, we need to go back up a level. And that should fix the issue. We will do the same for our public routes. And now let's head back to the browser and see what will happen. And we're greeted by a blank screen. Oh shit. Now upon inspecting the browser console, we see that we've got an error. It says that the angle bracket is an unexpected token. Seems like we have some issues with the JSX syntax. Let's go back to our code and fix this. It turns out that when we try to import our public and admin routes on line 6 and 7 here, JavaScript is already trying to parse the JSX syntax inside the file. The thing is, we can't really use JSX in anywhere that we like. We can only use JSX syntax inside the React component or React-related functions. So how do we fix this? The answer is simple. We simply need to render the component without using the JSX syntactic sugar. In other words, we need to call the underlying React function behind the JSX syntax, which is simply react.createElement. Let's go ahead and refactor the routes inside the admin routes file. Once we're done, we'll go back to the browser and our app is showing once again. Beautiful. After all these hustles, the end result is us having a very clean main JSX file, where we delegate all the routes logic into their own files. Now let's say our app grows larger and larger and the routes number in each of these routes files become too big. You could do the same thing again and split them up into another file. This file structure is extremely flexible and I hope it can help you to organize your massive project. Alright, key takeaways for this lesson. As our app grows, it is a good idea to split the routes array into multiple files. We can only use JSX syntax in the React components or directly in the argument of React functions. To create React components in other places, we should call the createElement function directly. That's it for now, and I'll see you again in the next one. It is certain that our app will throw an error at some point in time. It could be the user tried to visit a non-existing page, or the user tried to visit a restricted page without the appropriate permission. Now, in those kind of scenarios, it's only proper that we will create a custom error page to display the error to the user. Thankfully, React Router provided us an easy way to handle this situation, and it is something called the error element. Let's look at how it works. So let's just say we're throwing an error in our home component. Now, the default behavior of React for any errors is that it will bubble the error up, and if no one's catching the error, then it will render the default error message in our browser. So if we go to our browser, you can see that the default error page is not that pretty, and it's even giving us a suggestion to create our own custom element. Now in our route definition, we can actually add a new property called error element, and the value will be a custom React component, which will be rendered whenever there's an error. Let's go ahead and create an error element now. And we'll import our newly created error element back inside our public route.js file. And now if we go back to our browser, instead of seeing the default error page, we're now seeing our own custom error element. Isn't that great? However, we're not done yet. What if we want to show the actual error message in this custom element, which in our case will be hey ya, that was thrown inside the home component. Now React Router again has made it easy for us. To do that, we simply need to call a hook called useRouteError. The hook will return us the error instance that was thrown, and for us to easily display the error message, we simply need to read the message property in the error instance. Alright, let's take a look at the browser, and now we see Heya in the second line. So that was a quick overview on how we can make our own custom error page. However, our error page at the moment is very plain and simple. Let's spice things up a little bit with our awesome CSS skill. Alright, let's take a look at the result. Looking good. So now whenever you have up, you will be seeing this beautiful error page. One last thing before we end the lesson. It's very typical for us to provide a button to redirect the user back to their original location whenever an error happens. Let's quickly correct that button. We can make use of the link component provided by React Router DOM to send the user back. In a toProp, we simply need to provide a value of -1, and that will do the job for us. And let's also quickly style the buttons. And we'll test it out in the browser. Since the home page is the one that will throw the error, we'll first go to the contact page and visit the home page. And now if we click on the button, we're back to the contact page. Isn't that great? Alright, we'll continue in the next lesson. Key takeaways for this lesson. We can define a custom error element by providing an error element property inside the route object. We can send a user back to the previous location by passing the -1 to the toProps in the link component. Alright, that's it for now, and I'll see you again in the next video. GitHub Pages is a static site hosting provider. And as we mentioned in the previous video, routing in a single page application is not as straightforward as it seems if we want to deploy our application to GitHub Pages. So as a workaround, the first step is to change browser router into hash router. So we'll code the correct hash router function rather than the correct browser router function in our main JSX file. If you want to know the reason, please review the previous episode. The link is in the description. After we have shifted to hash router, let's take a look at the URL, and you'll notice that there's a hash symbol before the URI, and that means we're now using the hash router. Once this is done, we're now ready to deploy our app to GitHub Pages. Now we can't just deploy our source code to GitHub Pages because the GitHub Pages server is unable to serve the React source code. What we should do instead is to build and compile our code into a format that GitHub Pages is able to serve. Let's write a script for that. I'll create a new bash script here. If you're using Windows, you might want to install git bash to run this script. For Mac and Linux user, you should be able to run this script as it is. The first step that we want to do here is to terminate the script whenever there's an exception. We can do so by using the set-e command. Next, we'll need to run the build command to build our application. We're going to cd into the build directory, and then we'll create a new Git repository inside the build directory and push the content to our GitHub Pages branch in our GitHub repository. Let's quickly write the code. We will cd into the build folder and initialize a brand new Git repository and stage all the content inside the build folder and do a commit. Then we'll push everything to our GitHub remote repository. cd- will return us back to the folder where we were before. And now we'll make the script executable by adding the execute permission to our script. And let's run our script. Oh dear, we've got an error. Seems like the build directory is called dist rather than build. Let's change it into dist and we'll try again. Okay, seems like it's working. Now if we head to our repository, we should be able to see a new branch in the branch list. And now go to settings and click on the pages option panel on the left hand side. Make sure that you have selected deploy from a branch option here in the source drop down here and select GitHub Pages in the branch section down here. After that, click on the save button and wait for a few minutes. GitHub Pages should cook you something after that. Once that's done, you can click on the deployed link to visit your application. Now, oh shit, we're greeted by a blank page. And upon inspecting on the developer tools, the issue is our static asset is using an absolute path rather than a relative path. If you look at the URL of our website, the URL actually contains our repository name as the URI base. So we should add this behavior in our Vite configuration. Let's go back to our VS Code. we can simply get vid to use a relative path by adding a base property inside the configuration. And the value will be /. Let's rerun our deploy script. And go back to our GitHub pages and wait for a few minutes for GitHub to cook our application. After it is done, we'll go back to our application and refresh. And now we are greeted by our amazing app. And if I click on the links in the navbar, it's giving me the correct pages without any dramas. All good. And that's it. It is that easy to deploy our app to GitHub pages. We will continue in the next lesson. I'll see you there. If you would like to see more content, consider supporting us by becoming a member at my website, Acadea.io. It is similar to Patreon, but in return, you get a lot of premium tutorials and lessons. If you can't become a member, that's totally fine. We are just happy that you are here. We spend a lot of time and energy to produce high-quality videos for you. Feel free to check out our other videos on YouTube, and if you can leave a thumbs up, you will really make my day. If you subscribe, I would jump for joy, and I'll make more videos for you. Thanks for your support, and I'll see you next time.